Hello everybody, welcome back. Today we will be talking about section 4.2 of our geometry book and going over the following sections or the following items in the section. So here is basically what we're looking at. So postulate number 11, angle addition postulate, linear pair, supplementary, and supplementary postulate. So they are all linked together to make something wonderful and beautiful, if you believe it or not. Okay, so let's go ahead and talk then. Okay, so postulate number 11. So this is for this one talks about the following: to every angle BAC, there corresponds a real number between 0 to 180. Basically, a measurement for the angle. So just like the postulate for a segment, there is a postulate for an angle which tells you how big that angle is, just like how long the segment is. So here you can see the picture. You have an angle BAC, and for each one of those angles, I can assign a numerical value that says how big it is or how small it is. And that number has to always be between 0 to 180 degrees. Anything over 180 degrees, we do not consider, because then it's going to be, it's going to be outside of a triangle. So that's why we try to make it within this range. Okay, the converse of the statement. So if I were to kind of flip the statement, I want to know if this is actually true or false. So here's the converse then. To every number r between 0 to 80, there exists an angle that is going to be assigned to that number. And the answer for that is false. Because, right, if I gave you an angle that is 45 degrees, it's kind of like saying, how many angles are there that's going to be 45 degrees? The answer is there's going to be infinite. I can draw the angle this way so that it's 45 degrees. I can draw the angle this way, so that's 45 degrees. Basically, in the end, there's no one set angle that is going to be always 45, right? Because there's infinite number of ways that you can draw the 45-degree angles. Okay, so the converse of the statement will be false. All right, let's go ahead and move on then. Next one, angle addition postulate. So all of these should look somewhat familiar because it's parallel to the segment addition stuff that we did, or the segment things that we did in the previous chapter. So here in the angle addition postulates, here's what it says. Let D be a point in the interior of BAC. Okay, let D be a point in the interior of BAC. So here, I'm just going to go ahead and draw some arbitrary point D, which is in the interior. And if you remember, the definition of interior is that that point has to be on the same side of BA and AC at the same time. So it has to be on the same side of the half plane of BA and AC at the same side. So there's that point D then. Well, if that is the case, then the following must be true. And remember, think about this just like you did with the segment addition postulate. D has to be in the inside, just like saying, D is in the between the 2 points. So here, let me just go ahead and draw ray AD so you can see what I'm trying to get out of this. So according to the picture, you can see that there are 3 angles that are being formed here. BAD, and then we have DAC, and then finally, put it all together, we have the what we were trying to add to, which is BAC. So in this, as a conclusion, then the measurement of angle BAC is equal to the measurement of angle BAD plus the measurement of angle DAC. And right there, that is going to be our angle addition postulate then. And by the way, that little M on the outside right there means the measurement of the angle. So that's where you have the numerical numbers that you are assigning according to postulate number 11. Okay, so remember the M, again, that means the numerical measurement of the angle, like how big that angle is going to be. Okay, so after that, we're going to talk about linear pair and supplementary. So remember how I said that these are all connected, and you'll see why in a little bit. So linear pair, that is a definition right here. So there's no proof or anything like that. So here's what it says. Linear pair by definition means that you have 2 rays that are going to be opposite rays. So you can see in the picture, AB and AD are opposite rays. So that means they just form a straight line together and everything is collinear with A in the middle. Then we have AC, right? You have a point C that's not on that line. So then you can form ray AC. So you can see that right there in the picture. Then we can say that if all those conditions are met, then BAC, that angle, and BAD, that angle over there, so over here and over here, those are what's going to be form a linear pair. Okay, so linear pair, in essence, is kind of like saying you have two angles that are going to be formed by a single straight line and a ray that's not on the line. So you can see how that actually works then. And you can kind of guess as to, where this is actually heading, because if you look at those two angles, if you have a straight line, the measurement must add up to be that something that you're all thinking of right now, which is 180. So next, let's go ahead and introduce the idea of supplementary. Supplementary, again, by definition, so there's nothing to prove here, two angles, we'll go ahead and call them angle X and angle Y, are considered supplementary or supplement to each other, meaning if you take the measurement of one, add it with the measurement of the other, the result is equal to 180 degrees. So think about what we just said over here about linear pair and supplementary. If two angles are linear pairs, does that mean that they're supplementary to each other? Most likely the answer is yes. So then that's basically going to be our last part right there, the supplementary postulate. If two angles are linear pair, then they are definitely supplementary to each other. And finally, thinking about what we just said earlier, right? Let's think about the converse. If two angles are supplement to each other, are they going to always form a linear pair? Well, what are some thoughts? Pause it if you want. Okay, you've paused enough, right? I think you kind of can agree that the answer is going to be no. Because what I can draw is maybe one angle that is going to be 135 degrees. And then another angle, which is going to be 45 degrees. So something like this. And you'll notice that, yeah, the sum of those two angles will be 180. But you can't put them together like as a picture without having to flip it or do something crazy to make it so that they are going to form a linear pair. Because the bottom ray right here is definitely not the same. It's not the opposite ray of the other one to form that linear pair that you actually want. Okay. All right. Well, thank you so much for watching. I will see you next time. Have a good one. Goodbye.